These days, many applications need real-time processing, such as the financial trading, the data center, and automotive industry. The core of this real-time application is the processor with high performance and low latency. The technology which is trending for FPGA-based system is high-frequency trading or HFT. To increase the profit rate, what you need is the processor which can provide you high throughput with ultra-low latency to access data, to analyze the market information, and to execute the order with the response times as low as possible. First is traditional software-based. Most of the tasks are implemented on CPU by software, then connect to the network device to run the system on 10 gigabit Ethernet. This system has low cost and flexible to change algorithm or feature, but gain a lot of latency due to the overhead of CPU. Second is the hybrid computing. This design implements the application of user and TCP/IP stack on CPU. Then connect the 10G Ethernet MAC and transceiver PHY, which can be implemented by FPGA to transfer data. This design will help you improve the latency and still flexible to change algorithm, but you will gain more cost. Anyway, we can say that the design with software-based implementation will still give you a lot of latency. To achieve the real-time processing, let's compare the solution between the typical one and our design by Design Gateway. The general model uses software-based implementation with a low layer of hardware device such as FPGA, even though the system is flexible, but also have much latency from CPU overhead, while our design provides you full hardware design with ultra-low latency. Let me show you our design, which is FPGA-based implementation. User can interface to hardware by user logic. Then, connect to TOE 10G LLIP, which is the low latency IP for TCP/IP stack implementation, which could be fed to another low latency IP of Design Gateway, LL10G EMAC IP, to handle the Ethernet packet and implements PCS layer, which is the top layer of physical layer, and run with Xilinx transceiver, which configured to be PMA IP, and you can place this system to run your application. TOE 10G LLIP can split into 3 processing blocks. Control block to send the control signal to hardware through control interface. Transmit and receive blocks for data transmission and reception respectively. For the data interface, TOE 10G LLIP connect to the user logic with 32-bit streaming interface, while connect to Ethernet MAC layer with 32-bit XC4 streaming interface. And these two interfaces are compatible, so the system does not need the interconnect logic. Transmit path. To transmit the streaming data, the transmit block will receive the user data with a valid signal when the TOE 10G LLIP is ready. Then, the TCP packet is built and sent to LL10G EMAC IP with the valid signals when LL10G EMAC IP is ready. The temporary buffer is added to store the transmitted packet for the case when the packet is lost and data retransmission is needed. For receive path, TOE 10G LLIP receive the data from LL10G EMAC IP and filter TCP header to receive only the related packet with the valid signal. Then, send the user data to user logic with the same format. Our design is extremely easy to connect to any of the application. For HFT system, user can place the design to connect between the HFT subsystem with the venue like this. And if your application needs more sessions to transfer data, you can just place another system just like this. Also, our demo is designed to measure the latency time in both directions by including the test logic, the data generator, the data verifier, and the test software. And here's our latency time. Compare the latency time of TCP/IP stack implementation with the different method from the different source. The minimum latency from software base is 112 microseconds for TX-path and 185 microseconds for RX-path. From another FPGA vendor, the TX latency is 80 nanoseconds and RX latency is 93 nanoseconds. While Design Gateway can provide you 6.2 nanoseconds for TX-path latency, which is 3 times lower than another FPGA vendor, and 46.5 nanoseconds for RX-path latency, which is 2 times lower. If you are interested in our low latency IP, you can check it out in our website www.designgateway.com or just click the link in the description below.